Hi and welcome everyone. In this video, I want to go over the cross product. So, and do some examples and the properties of the cross product. First, let's take a look at the definition. The cross product of two vectors, u and v, in R3, very important. So the cross product works only in R3, is defined as a vector w. So just remember, it is a vector and not like dot product. It's not a scalar. And this is also, W is also in R3, that is perpendicular or orthogonal to both U and V. And we're going to see what that means. Now, the way you write the cross product is W is U cross V. That's how you say it, or sometimes you might see this notation in some books. The direction of W is given by the right hand rule. We won't do that in this video, maybe in the next video, or in physics you're going to see that, how they use that, the right hand rule. The magnitude of W, which is the magnitude of U cross V, is the area of the parallelogram that the vectors span. And I'll show you that later in the same video. Now let's first understand vectors in R3. When we say R3, that means each vector has three components. You can also in R3 write that as U1 times I, U2 times J, and U3 times K. Now I is a unit vector in the X direction, J is a unit vector in the K direction, in the Y direction, or y-axis, and k is a unit vector in the z direction. The formula for cross product, if you want to remember this, you can just the determinant. So you can write always ijk, the components of u and the components of v. So the component of I of w vector is just this minor, so it's the determinant of that. So matrix minus, if you use a cofactor, you can just say plus -1 to the power of 1 plus 2, but then you can just remember it's just minus. And of course, the component of J is the determinant of this matrix, and plus again, and the component of K is the determinant of that matrix. So that's a simple way to remember without memorizing the formula. So if you calculate those, the I component is again that times that minus that times that, and that goes for all the three determinants. Is just calculating the determinant of a 2 by 2 matrix. Or you can write that W as the first component, that's the second component, and that's the third component. These are all the same. Now note, W is orthogonal to U and V. So if you do U dot W and V dot W, you're going to get 0. You can use these components and do dot product with U1, U2, U3, and you'll see if you combine all the terms, then you're going to get 0, same as V. Now, let's do an example here. I picked a vector 1, 2, 3 with the components 1, 2, 3, and a vector v 3, 0, 1. So W is U cross V. So you take the U vector and the V vector, and you write the components of U, the components of V, and then let's see for the I component again. I wrote that determinant. For the J component, you take the determinant of that matrix, don't forget the negative sign here. And for K, you take the determinant of that matrix. And you can just calculate those. If you do that, you're going to get 2i plus 8j minus 6k, or you can write W, the components 2, 8, and -6. Just to check, see if your answer is right, you can do W dot U with numbers is much faster. So that's 2, 8, -6 dot 1, 2, 3. And again, if you do the dot product, 2 times 1 plus 8 times 2 right here, and plus -6 times 3, and you get 0. Same thing with W. If you do the dot product with W, you are going to get also 0, so our answer is right. If you want to find the magnitude of W, that's square root of W dot W, or you can use or you can say, if I write that is square root of W1 squared plus W2 squared plus W3 squared. Now let's go over the properties of the cross product. If U and V are vectors in R3, then U cross V is orthogonal to both vectors U and V. We saw that. The angle between U and V can be found by doing the norm of U plus U cross V, which is W, is equal to norm of U times norm of V times sine theta. So, or you can say isolate sine theta, write it like that, or just say theta is sine inverse of that. So here it's we're using sine as opposed to cosine for the dot product. There is a proof for that, so please research that, or I'll just do that in another video. If U and V are parallel, very important, then U cross V will be equal to 0. So if you do the cross product for two vectors and you get 0, that means those vectors are parallel. The magnitude of U cross V, or the magnitude of W, is the area of the parallelogram having U and V as adjacent sides. That's what we said. But I called, when I started, I called this span, but then later on we're going to use, we're going to learn in the next videos what span is. But here, just to see the picture of what's going on. So we have, these are adjacent vectors, vector U and vector V. So if, and this is the parallelogram, the area of this parallelogram is going to the base times the height. But what is the height here? It's, if you use trigonometry, you see that the height is just norm of V times sine theta. So that's going to give you that. So the area is just going to be U, the norm of U times that. So, and I write that here, I wrote that here, area is base times height. The base is norm of U, and the height is norm of V times sine theta. So that's the area, and we learned that the magnitude of U cross V has the same formula. So I think that's good for this video. Please watch it a couple of times. The calculations are pretty easy. I might do some proofs in the next videos. Thank you for watching, and I'll see you in my next video. Have a good one.